good morning or afternoon or evening, depending where you are in the world. There's only a few people on the call, which is okay by me in the sense that I'm happy to kind of make it more conversation. I have some slides that I'll go through, but please feel free to just interrupt at any time, ask questions, make it more kind of discussion. As one other side note, for my job, I'm at the AUVSI, which is the Association for Uncrewed Vehicle, what is it? Uncrewed Vehicle Systems International Exponential Conference right now. And that is a conference that is kind of specifically to showcase emerging drone technologies and for companies to kind of bring their technologies to the conference to show others and to talk about kind of current trends and regulatory challenges. So I threw together a couple more links in my slides here based on what I saw there yesterday. One thing that potentially could be very interesting for kind of Red Cross drone use cases in the future. And we'll continue to add some more information to the slides that I'll give to Dan to make publicly available to everyone on the call as well. So just kind of a unplanned but interesting side note, I'm also learning more about emerging drone technologies this week as we talk about this. So the requisite question, can everyone see when I'm sharing? Great, thank you. So there's several topics that I'm going to go through. Like I said, please feel free to jump in with questions. I'll do kind of for each of these topics here, a quick overview of what it is, why it might be useful, and a quick thought on how it could be useful to future Red Cross operations. That's more the thing I want, hopefully, people to take away from this is, kind of a slightly broader view of the survey of technologies enabling drone-based applications, and kind of that question in mind, how can this stuff help our operations in the future? And definitely not something I have all the answers to, but something I'm hoping to kind of enable us thinking more about these questions. So this is definitely not intended to be a comprehensive review of any individual technologies or drone capabilities to enable better future operations. It's a very brief survey with a series of links to things, an overview of each kind of thing I have in here, and then a series of links to companies that are producing things that relate to or kind of implement each of these emerging technologies or innovative technologies, so that people can go explore these things on their own, reach out to other kind of, these are not companies that I am affiliated with in any way. They're just, as in my surveying, in my work, and in my interest in drones as a hobbyist as well, I've come across these things and think they're worth sharing. So a little bit about myself. As Dan mentioned, I am an American Red Cross volunteer. So I'm an ITT ERU roster member. I've done a couple of trainings now, trying to expand my skills into IM, relief, other areas. So, make myself more deployable, have a wider variety of knowledge across Red Cross operations, and, interested in continuing to maintain my involvement in the drone working group and everything we're doing in that space. My day job is an autonomous systems engineer. So what that means is mostly writing software and doing hardware integration. I don't really build hardware myself, but I put hardware together a lot and add software to it to enable fleets of drones to work together to do things. Other than that, I like to play hockey, and I kind of am a hobbyist, multi-copter builder and flyer and tinkerer. I'd like to do more learning how to fly fixed wing drone aircraft, but I live in the DC area and it's a huge pain to get somewhere to fly, so I get to do it much less often than I would like. So the first thing I wanted to talk about is just kind of a quick overview of one of the main kind of application areas that my work, my job work has taken me into over the last couple of years. I know this is a little bit of a busy picture, so I apologize, but I'll try to kind of walk through what this is showing. And this is one project that we're actively, working on along with a number of other, companies that are looking for solutions to these problems as well. And the idea here is, you can see kind of the background image shows a cartoon of the power grid. Um, every year, power companies, spend billions and billions of dollars on storm response. So after a big hurricane hits, especially in the South, for example, in the United States, um, you know, power lines, substations, transmission lines all get damaged throughout those regions and cause major power outages, right? This is the kind of stuff you read about in the news. Right now, to assess the damage requires sending people out in trucks, or, people, they use drones, but, people, one pilot with a drone at a time to go fly along lines and collect pictures, or people to go on the ground and inspect things manually or take pictures of things, these things being poles, wires, towers, that kind of infrastructure. And it takes, a lot of money and a lot of time, and in a lot of areas can be high risk to the people that are doing this assessment. And the goal of this assessment is to, figure out where the failure points actually are, which is something that they can't do from automated sensors, and get the repair trucks and people where they need to go to get power back on for everybody. So, what's been identified as a potential solution here, and this is something, a project I've been working on, is enabling fleets of drones to go do that kind of inspection. And they can do it faster, less expensive, and with less risk to people than operations before. And so some of the enabling technologies for that are, one, heterogeneous drone fleets. So what that means is combining fixed wing aircraft with coarser sensing capabilities, with copter type aircraft, with kind of more high fidelity and localized sensing capabilities into a team that can, work together to identify areas that need to be scanned or looked at, use onboard sensing capabilities to assess damage in real time, relay that information to each other in case, a fixed wing aircraft flies over an area and sees, well, here's a anomaly that I'm seeing, but I can't get quite enough information to figure out exactly what happened here. I need to automatically dispatch some copter drones to go look at that area more closely, relay that information across the team and back to human decision makers over some sort of communications network. Right here, I'm showing 5G because that's kind of where the future is going as well. So that people, decision makers in dispatch centers or headquarters type locations can make decisions about where to send repair trucks and people. And all of this happens with minimal human supervision. So humans might be inputting information into the system to say, here are some large areas of interest that need to be covered, but nobody is flying any drones with joysticks. Because being able to scale that up is like I said, kind of takes a lot of manpower and a lot of time and a lot of money. And the idea is to use this technology to reduce those things for this kind of application. So this is one of many potential use cases combining a number of technologies that I'm going to get to in a second. Just happens to be one that I'm fairly familiar with, but can apply to a lot of different applications. So getting down into the individual technology areas I wanted to talk about, my note in here is just a reminder. This is a very brief and limited introductory survey, not intended to be a full description of any of these, nor does it include, all different depth, breadth of technology areas related to, innovative and emerging drone tech. So the first one I want to talk about is platform autonomy. I'm going to skip back and forth between slides here a little bit. So, what does autonomy mean in terms of drone technology? Here's one chart. There's, this is not standardized, but I thought it was a good representation of levels of drone autonomy. So basically, it ranges from needing a person to be having hands on a joystick, actively controlling an aircraft at all times, all the way up to effectively giving a drone an objective or a mission and the pilot never having to touch anything again after giving the drone a mission. And there's a number of levels in between where, excuse me, it can be a mix of pilot inputs on joysticks versus pilot monitoring. But all of this in this particular kind of first technology area is focused on a single drone being able to do things on its own. So like I said, I've kind of taken publicly available information from a number of different companies to talk a little bit about what's in these technologies. So Skydio, I assume a lot of you have heard of this company. They have been developing and promoting a lot of really mature AI-based autonomy for drones. So the things that enable, giving a drone an objective like follow me or scan this radio tower or perform an inspection of a bridge without crashing into anything and collect imagery and analyze it. All of those things are enabled by these underlying technologies such as real-time 3D mapping. So being able to, using LiDAR and cameras, collect information and build a map as the drone is flying, do object recognition on board, and coming out of that, obstacle avoidance. So making sure that as a drone is flying, even if a pilot is not controlling it, it can avoid both still and moving objects in its path. Motion prediction, so if it detects an object that's moving, predicting where it will go to make sure it avoids hitting it. Pilot assistance for when a pilot actually is, helping control the aircraft. So, stabilization, those kinds of assistance things, and workflow automation. So, the kind of being able to, on the computer, on the drone, sequence tasks or sequence maneuvers together to be able to, accomplish some objective without having to have a pilot be actively providing input. So these are a bunch of things, like I said, that Skydio, who is one of the companies I suggest everyone go check out related to autonomous systems, has put out there. Why is this useful? Platform autonomy, so a single drone being able to fly without pilot input makes it a lot easier for anyone to fly drones for mission critical applications. So reduces the training barrier to entry for using drones effectively in operations. And in reality, a lot of times pilots can be very good, but for specific tasks or maneuvering a vehicle, which is really just a lot of math, computers can be better. So for example, if you think about flying an upward helix shape, so circling around and moving upward around a transmission tower, that's a hard maneuver for a person to master, but it's a fairly straightforward maneuver for a computer to crunch the numbers while a drone is flying and have it fly some route that does that to collect imagery of a transmission tower. What's it used for? Platform autonomy, really used for everything. This is not a complete list. So search and rescue, sending drones out to say, okay, see if you can find people in some area and fly this pattern so that you're looking at, at the ground or in buildings and are looking for people or other sorts of damage. Utility and asset inspection, mapping and data collection, and any other situational awareness recently. Any drone that can fly itself that's got a sensor on board is going to be able to provide people information. How could it apply to Red Cross operations? Here's where, like I said, I've got some thoughts, but this is really where I want the, if it happens, discussion points to be. Also, I want people to kind of take away their thoughts with themselves out of this on where they think this could go. But in my view, more personnel can become drone operators with less training required, and they can be qualified drone operators, not just, oh, I can put up a drone and do something, but they can really use drones for useful things without needing to really understand or have to master, just stabilizing an aircraft in a little bit of wind. Red Cross personnel can deploy drones in a safer and more efficient way to collect relevant data. So it kind of comes out of, just not having to have as much training or spend as much time on joysticks to be able to do useful things with drones. So again, for each technology here, I'm also going to have kind of a set of links at the end. Once these slides go out to everyone, these are just some resources to go read more and find companies that are working in this space. Fleet management and autonomy. So building on top of platform autonomy to enable one pilot to multiple drone operations, or one pilot to many drone operations, or even not needing a pilot or supervising human at all. So, you can kind of imagine the benefits of this pretty easily. Imagine you're mapping a large area instead of needing either, 6 pilots to go take drones out and map some area, or one pilot to make a whole sequential series of flights to collect data. One pilot can take 6 drones out to a field and then put them up in the air, give them this objective, like map within some boundary, and cover a much large area with much less time and resources than before. And mapping is just one potential use case here. So this is kind of another Skydio diagram. I'm not affiliated with them at all, just to be clear. I just think they have some really good marketing material. But they have this kind of path here where they are looking from what they call stage 1 through stage 5 autonomy, where stage 1 is single platform, moving all the way up to one pilot controlling many drones, and then even getting to drones as a service. So through communications and cloud-based capabilities, you don't necessarily need a person in the same geographic location as a drone or multiple drones to fly it. You can have, almost like a dispatch center for 911 operations. Your drone pilots or drone supervisors really are in central or dispatch centers around the world and can control drones that are nowhere near them geographically around the world as well. This is just a quick view of a fleet management tool. So having that central knowledge, if you've got a fleet of drones that can do things together and have one person controlling them, what an interface might look like. This is from Skyward. Again, I have no affiliation, but they have some good marketing material on what their product provides. You can see these kind of black and orange dots with lines are information about where drones in a fleet are flying and have flown, so that, again, enabling one person to track many aircraft simultaneously. Drone in a box solutions, kind of a separate enabling technology for these kind of extended duration operations. Basically is really what it sounds like. So an automated box, literally, that a drone can sit in, be protected from weather, from other elements, can automatically or autonomously, kind of, the box can open up, the drone can go out, fly missions. These can be scheduled, these can be ad hoc. But the drone in a box solution, right, one of the key things is it also provides charging capabilities, so that a person can remotely launch or schedule launches of these drones that come out of their box, without needing to have a person always there plugging it in for charging afterwards, or, like I said, kind of building on autonomy, joysticking the drone around. So the value of some of these things really starts to multiply when you're incorporating more than one of these enabling technologies into a solution. So drone in a box plus autonomy plus what I'll get to in a second with wireless charging, right, gives you a system that the only time a person ever needs to touch it, even while it's doing things like inspection over the course of weeks or months, or even years, is if it does break or something breaks, or to do maintenance on it, not to do routine charging or anything like that. How could this apply to Red Cross operations? For this one, I'm not exactly sure where this would support operations, right? It's highly valuable when you have set locations that you need to do things, whether it's mapping, used a lot in agriculture and asset inspection, right? You can have these out on a farm or next to transmission towers, and they go out and do routine inspections all the time to monitor for crop health or monitor for transmission tower failures, or even predict transmission tower failures. in terms of a kind of mobile, more ad hoc Red Cross operation, I'm not sure, but I'd like, again, people to kind of take away these questions and consider them for the future. So I mentioned one other technology, automated wireless charging, that's it's built in or kind of a part of some of these drone in a box solutions. Basically, what it is, and here's a picture of a Weebotic power pad. It is a pad that has basically an induction coil in it that produces an electromagnetic field that, along with the kind of receiver hardware on a drone, can, the same way some of you probably put your phone on a wireless charging pad, it's the same concept here, but with a higher voltage and more power. So you can land a drone on this pad and it will charge automatically. No need to plug anything in. Again, better enabling continuous or longer term operations without needing a human in the loop. One of the interesting challenges here is how to do this with fixed wing drones. As you can imagine, right, it's fairly straightforward to, even at this point, right, precision land a copter type vehicle that can hover onto one of these pads. Much harder to do that with a fixed wing aircraft. So I actually talked to one of their reps yesterday here at this conference, and that's something that they are starting to get into, talking to other partners about. There is no good solution yet for it, but keep an eye out for the future. Again, some more links. Sorry, I can't see the time right now. I want to make sure. Okay, about 7:56. Just want to make sure I'm not running too far over. So edge to cloud, data pipelines, and digital twins. I don't know, bunch of words there. So what that really means, that's kind of two separate but related things. Edge to cloud data pipelines. So basically answering the question, how do you get data that you collect from not just one drone, but many drones across many operations, stored in a central location where it can be then not just stored off on a hard disk, but used for analysis potentially after every mission, and kind of building on data that you collect every mission. So one of the use cases, if we talk about energy or power grid use case, whether you've got one drone or a fleet of drones or a fleet of people flying drones, you're collecting a lot of data, a lot of imagery, a lot of LiDAR data about or on those transmission towers, transmission lines, distribution poles and wires, and over time we want to be able to do things like track changes in condition on those assets that might indicate when something is going to fail, so that you can do a better job of being more efficient in repairing things before they break, without having to continually do maintenance on everything all the time. So it's that balance of time and expense and manpower over time that having a kind of edge to cloud pipeline can really help with, along with drones that can actually be used effectively to collect the data, such as a combination of drone in the box solutions and platform and fleet level autonomy. Digital twin is a term that's kind of been growing in popularity over a few years, and basically refers to a 3D model or representation of a physical thing in the digital world on a computer. So again, kind of referring back to power grid, a digital twin could be literally a 3D model of hundreds to thousands of square miles of energy asset infrastructure. So 3D point cloud models with overlaid 3D imagery or photogrammetry of all of this infrastructure over a large region, so that one, you can build, train, and run algorithms to predict, like I said, predict potential points of failure, or even have literally like a digital world or viewpoint where a person can go in on a computer and virtually fly around in this 3D representation of the grid and look at the real world data that was collected for each transmission tower um, uh, um, after it was collected from some central location. So again, it helps, if people can go look at reliable information in a 3D view and look at, the insulators and wires on a transmission tower and be able to tell, when one is starting to fail or when one has broken or that everything's good, then that saves a ton of time and manpower and expense where, the current state of operations for that, for the most part, while they're, companies are transitioning to use these technologies, is people going out to the field and taking pictures and looking at them after, or literally manually inspecting everything in the field, which, like I said, takes a lot of time and manpower and effort. So how could this kind of thing apply to Red Cross operations? Again, just up for discussion, but you can imagine monitoring temporary housing and population movement over a period of time. So if you're using drones to, assess where temporary shelters have come up, and, where people have gone to after a disaster, or where they are going to, how to best, provide resources or assistance for an operation, this kind of, automated operations and being able to kind of build this kind of world in real time, while 100% it raises security concerns, and there's a lot you need to think about in terms of data security and data privacy, can be very powerful in enabling someone to look at, okay, what's happening over time, where do we need to move the operation to best provide assistance. Same thing for assessing damage from natural disasters in both the short term. I know that's something that I've read about in a number of the papers, but also, automatic or autonomously assessing, and analyzing changes in damage or changes in, the natural environment after a disaster over a longer term is something that, data pipelines and digital twins can provide the ability to do, which maybe can help better inform operations, kind of prioritization over longer periods of time as well. I didn't skip to the image this time, but on the left-hand side, what you see is, a computer rendering of a digital twin. So the real world, right, has actual infrastructure in it. A digital twin is a literal 3D representation, along with other metadata of the physical things in that digital environment that someone can go look at. And the way that data on the bottom right here, gets to that digital twin is via the edge to cloud data pipeline. So there has to be some sort of communications network, obviously, and drones collect imagery, they or other types of data, maybe do some processing of that data at the edge, meaning on the drone with some onboard computing, and then send that data over some sort of communications network, which many times, especially in kind of standard applications, will be cellular or satcom networks to the cloud. There doesn't have to be a neural network involved in this. I just kind of like this picture I found online, but to be stored and analyzed later on, and can be accessed by people from anywhere around the world, right? Any central location. One thing this doesn't, well, one of many things this doesn't show is that not just one drone, you can have n number, dozens, hundreds of drones all collecting data, and the cloud part can help with stitching all of the data together, especially as you really scale up the amount of data to build these digital twins and enable this type of analysis. Another set of links and a brief YouTube video talking about what are digital twins. So those are that kind of concludes the survey of some of the baseline enabling and innovative technologies that I wanted to cover. Right. Again, some of you might be familiar with some or all of those, but hopefully some of the resources are useful. Like I said, not a complete survey, but all of these enabling technologies, I think, are going to be have the potential to be game changers for a number of industries, are already starting to do so, and hopefully, in the Red Cross operations, internationally and nationally, we can build on some of the things that are being done in these spaces to help our own operations. I included a few more links here on some specific examples of drone and robotics usage in civil applications. I'm actually gonna maybe switch back and forth a little bit. Um, Excuse me. I didn't put everything in the slides, but I wanted to kind of share this article. So some of you already know about this, but in Puerto Rico, I believe, several years ago, AT&T deployed what they call the what is it? Cellular on wings, cellular network on wings. It was a drone that has yeah, here it is, a drone that basically gives you a cellular network connection. So effectively, a flying antenna and modem, so that people could connect when infrastructure was down to be able to communicate with families. So this was used by some humanitarian operations themselves, but also just by affected people, affected populations. This enabled them to get connectivity, to talk to, reach out and give information to people they needed to reach when the actual infrastructure was down. So this was several years ago, but I just think is always an interesting example of applying this type of thing to a humanitarian operation. Reforestation, there's a company, Drone Seed, I think they're based out of Seattle, that is using drone swarms or drone fleets to plant seeds much faster and more efficiently, more effectively than humans could go do it to rebuild deforested areas. I talked a lot about energy asset inspection. So there's several links here on, one, how Florida Power and Light is using drones, how PG&E are using drones. Some of this doesn't quite get into the fleet level scaling and drone swarm and fleet autonomy stuff we talked about yet, but that's what some of these companies are investing in for the future. And then a YouTube video that has some interesting information on energy asset inspection. In addition, especially in the US, a lot of states, North Carolina Department of Transportation is kind of one of the early examples, but a number of states are following suit, are doing a couple things. One, leveraging drones and edge to cloud and digital twin capabilities to do to reduce their costs for infrastructure inspection. And the other thing that a number of states are doing are building UAS test sites or test ranges to be able to have safe, dedicated regions to test these emerging technologies, and have partnerships with the FAA, Federal Aviation Administration, to make sure they're doing that safely and within drone regulations. A quick thing I added last night while I'm here at AVSI Exponential is the conference, are a couple of links. Like I said, I'm going to build on this on just more interesting companies producing technology that isn't quite covered in everything that I have above, but I think is useful for people to learn about, to consider how we can incorporate these into Red Cross operations. One of these is a company, very early startup called Wing Expand. I talked to them for quite a while yesterday. They make a fixed wing aircraft that, as you can kind of see, I know it's a little blurry in this picture here, basically the wings can extend out or fold back in, or collapse back in. They don't really fold. And the tail of the aircraft can fold down as well. And basically this thing costs about $12,000 now, they said, fits in a backpack, and can fly for a couple hours with not a huge, but a couple pounds of payload, meaning you can carry a camera or sensor, and has built-in kind of flight autonomy, so it's easy to fly. So this kind of struck me as one potential very useful, easy to use, not crazy expensive, although definitely not cheap, and really extremely portable drone platform that could enable potentially enable Red Cross operations in the future. And there's a number of other technologies here. Like I said, I'll be updating these things. The last thing I wanted to talk about before getting to some Q&A or anything else someone wants me to give more detail on are regulatory considerations. So many countries around the world, if not most of them, have governing bodies for their airspace. I don't know much about a lot of other regions, right? There's tons of resources online to look into that kind of thing, but I focused on highlighting a little bit of data about drone regulations in the US. And some of these technology areas, while very exciting and potentially very applicable, also come with regulatory challenges, especially under the FAA, Federal Aviation Administration. So currently drone operations fall under what FAA refers to as Part 107. There's a number of regulations and restrictions on flying aircraft under Part 107, size of aircraft, weight of aircraft, different classes, and then also just operating restraints like beyond visual line of sight, or BVLOS. The FAA prohibits flying a drone beyond where you can physically see the drone if you were the pilot and you have to be co-located with it. Now, they have started over the past few years providing waivers to a variety of companies and users of drones to be able to fly beyond visual line of sight, but they are ad hoc. They're one-off waivers. They're specific to locations and you have to prove that you've mitigated a lot of safety risks in order to be able to get that kind of waiver. And another one very applicable other restriction is right now there has to be a pilot for every drone. And even if the drone has autonomous functions, there still has to be a person in the same place as each drone that has a joystick that could take over, or a transmitter that could take over if need be. So these are things that people can be granted waivers for, but it is difficult to get waivers and requires a lot of making sure you can prove that you're mitigating risks, so your drone's not going to get out of your sight and then crash into someone and kill someone, or cause a lot of damage. That's really the concern, or hit another aircraft. So there are a number of things in progress, with the FAA, with industry, where they're working together to solve some of these challenges, to make it, to come up with safety solutions. And some of these are products that are here at AUVSI that I'll add some links to enable, in-air collision avoidance, better communications, so someone can monitor drone progress, so that people can start doing more with beyond visual line of sight and flying multiple drones per person, or flying drones totally remotely, to enable some of these, unlocking really the potential of UAS, which we won't really fully be able to do until we solve some of these regulatory challenges as well. So that's pretty much everything that I had. 8:12, not too bad. I wanted to leave some time for questions or discussion. So, are there any questions? Is there anything anyone would like me to go back to and provide more detail on, or any topics people want to bring up to discuss?
Kevin, there was one on the chat. I know Dan had to drop off, but actually it's kind of a three-parter. You may want to walk through that.
All right, let me try to get to the chat here. Chat. Okay. All right. Some questions for the end. So does object recognition and motion prediction extend to the motion of other moving things? For example, identifying a bird or person and then predicting where that object will be at some future point in time? Well, the short answer, yes. So there are algorithms in use today, a variety of them. And that object and motion prediction definitely extends to other moving things. That's a key enabler for solving some of these safety mitigation and regulatory challenges as well. So let's say, a power company, Florida Power and Light, wants to put up a drone to go scan a length of transmission towers and transmission lines. If they're going to do that beyond line of sight, and with kind of a person operating it without being located in the same geographic region, or flying monitoring multiple drones, where the drones are doing this autonomously, the drones have to be able to do in-air collision avoidance. And part of that means, not hitting transmission towers or other objects that are non-mobile, but also not hitting or planning their route to avoid and updating their route in real time in the air to avoid hitting, an unpreviously seen moving object. So, like you said, a bird or even another drone or another aircraft. There's a number of algorithms out there that can look at what we call a track. So a series of detections of some object over time and kind of, mapping that to a some sort of function, mathematical function of how it's moving, and then applying that function to future time steps to predict, where it's going to be in half a second, 1 second, even, many seconds or minutes, depending what that object is. And so there, like I said, numerous algorithms that support that kind of capability. And they vary in complexity when you're a copter that's looking kind of down, looking at people and watching them move, versus a fixed wing, jet drone that can fly hundreds of miles an hour and needs to make sure you don't hit any other planes. But short answer, yes, definitely something that's part of that. Two, what kind of safety enhancements you've seen for situations that have already become an emergency? That is not just avoiding flying into a building, but minimizing risk/damage after the drone does collide with something, loses connection with the base station, or loses flight power. Yeah, so those are kind of three different things there. So if a drone does collide with something, that's a really interesting question, because I haven't seen really anything other than kind of built-in stabilization that a drone will do anyway. If it crashes and bounces off something, it will still be trying to stabilize. But a drone crashing and doing something to minimize risk or damage after crashing to the thing it crashed into or other things on the ground, I haven't seen much in particular, and I'd be really interested to look into that more. In terms of losing connection with the base station, that's something that is a pretty well established kind of fail-safe mode for a lot of different drones, ranging from hobbyist all the way up to really state-of-the-art, top-of-the-line drones, manufactured drones. So even hobbyist drones have things where if you lose connection with the base station, you can set a fail-safe where it either stops and hovers, or lands where it is, or turns around and, assuming it has a GPS signal, kind of another assumption, comes back to its launch point or a rally point and lands at one of those locations without needing a person, to even be able to connect to it. Obviously, as it, if you've lost connection, person can't connect to it. In terms of losing flight power, again, that's kind of another thing where, for drones that need to constantly have their motors running, I haven't seen much in the way of anyone implementing things that deal with that. However, in terms of fixed wing aircraft, I know there are, I don't know if this applies to hobbyist drones as much. I haven't done as much with fixed wing, but especially, drones you can get from manufacturers, they will have some fail safes built in where they can recognize, if they may have a small spare for the kind of onboard computer, and if the power dies on that supplies power to any motors or propellers or anything like that, if the computer can detect that and keep itself running for a little bit longer without having to power all those other higher power draw electronics, then it can have the aircraft, it can just kind of float itself hopefully to a place where it can land. Obviously, you're going to be pretty limited in if you aren't able to draw the power to run motors or things like that. So I've heard a little bit about some companies dealing with that, but I don't really know a lot about it at all. So an interesting area, I think, to look out for. 3, is there any talk about easy repairs, easy upgrades, standardized battery packs, swappable components, etc., and not just having to buy the newest DJI model and accessories every couple of years, the same way you need to buy a new iPhone every couple of years? Yes. So, from DJI, I don't know, I'm not so sure about that, but a number of the companies here at AUVSI have developed drone platforms where it's much easier to kind of swap out motors or swap out, propellers are easy on everything, but motors or other individual parts, obviously there's a limit to that, right? A power distribution circuit board is probably not something, people are gonna replace, although I can't say that for sure. But definitely, standardized battery packs, that's something I haven't heard a lot about. Kind of like Apple builds batteries into their phones. DJI has their type of battery, and other drone providers, many of them just use kind of standard XT60 or XT90 connectors, and you strap a battery on. So that makes things a little bit easier. But standardized across the industry for just kind of like, a standard locking mechanism battery, I haven't really seen something like that, but we'll definitely keep an eye out for it. But in terms of swappable components, at least, among the same, companies' models, I think that's something that some companies are starting to move towards. So okay, those are the questions that were in the chat. Anyone else have any questions or anything they'd like me to go back to?
I have one question, Kevin. This is Paco talking from Geneva, Global Search Lead. Thanks for this master class, man, of this. I'm not an expert on the drones thing. I'm normally like more in the disaster management side and so on. So, Kevin, given all this wealth in terms of knowledge and so on, what would be like your recommendation, taking into consideration that, from my perspective, we need to operate with something that is cheap. We need to operate with something that is easy to use and operate, something that would make like the maintenance easy to operate in or easy to maintain in a country and don't need to ask for spare pieces or whatever.
Yep.
Easy to transfer the capacity to the national society and so on, in case they have the interest and so on, to be transportable, like fully transportable, and not something that would require like to be transported in a separate than in a luggage, a personal luggage and so on, because time is of essence.
Yeah.
And then the security related, and this is linked to what Daniel what Dan was mentioning, right? That from our perspective, if you are alone and you deploy with a drone and then something happened with the drone, is you as an individual. If this happened in the saying of the Red Cross, then it's the whole institutional reputation that is at place, no?
Yep.
Then so these are kind of the factors that from my side are kind of more relevant. So given this, because I think that there has been like a lot of progress within the group that has been discussing on this, no, and a lot of things also with Brent that has been progressing in terms of framing like the whole thing and so on. So I guess that's and also like linked to a meeting that we will be having like in early June with the disaster and crisis working group. So this is mainly like the disaster management or international from each one of the national societies. There is an opportunity in there to come with some sort of, okay, this is more or less the model, right? The model, this is the idea, this is how it will work, these are the services that we're planning to provide, and which are the national societies that might be interested. So we offer them sort of the platform to engage, right? But to engage with a clear commitment to be able to, okay, yes, I'm going to commit on this, I'm going to train my people, and I'm going to create like this capacity to be available for future deployments, you know? And I know that, of course, we will need to pilot and test at the beginning and so on. And it's not like we will have like 10 national societies ready to go in 1 year, but at least that we put this forward and we are transparent also with the membership, with the different national societies on the progress, but also if they have the interest, okay, here is the platform or here is the way to connect into this initiative, no?
Yeah, so I think there's a lot in that question / statement. So, part of what I want to introduce out of this is for people to go think about that, right? Which of these things are really applicable to Red Cross operations. How do they impact operations, and how do they enable us to do things safely? I definitely don't consider myself to have all, or even, a small portion of the answers to that right now. But I'm hoping that this information and some of the links to, what is really being produced, that, we could, purchase and use, to inform some of those, the answers to some of those questions. I mean, one of the, sorry, I know I have a bunch of windows up now, this wing expand thing, not just on its own, but kind of what it represents, kind of resonated with me in terms of the Red Cross. It can fit in a backpack. One person can bring everything you need to fly this thing in a backpack. It's got autonomy on board, right? One of the enablers that makes it easier for people to get trained up on it and fly it themselves, easier to introduce someone to it and teach them how to use it. It's got a, kind of a clear set of like parts that are easily replaceable. So like these collapsible wings, each of them is a separate piece and they're easily replaceable. They are carbon fiber. However, in a pinch, you could, I know, again, I know we're getting into some more needs that you would have if you were to do this, but you can 3D print a replacement part and use it temporarily, and the aircraft will still operate safely, while if you need to wait on a spare part or something like that. So this is the kind of thing that incorporates kind of, multiple pieces of new technology. And, like I said, right now, they told me it's about $10,000 or $12,000. That's very expensive for the Red Cross. However, compared to a lot of the stuff, right, a lot of drone companies develop things with a military focus because the militaries have a lot of money, especially the US military. But so hearing things that are getting away from that, trying to focus on humanitarian, even if it's not quite there yet in price, but they're trying to make things cheaper. They're trying to make things easier to repair. They're trying to make things easier to use. Kind of combines a couple of these technologies into something that, maybe in the future is really useful for us. And hopefully other companies will kind of follow this as well. So, in terms of safety, all of that autonomy I talked about is one of the main purposes of that, is to enable, okay, if you've got someone, getting someone to the point where they can fly a drone takes a lot less training and is a lot safer, because the things can, prevent crashes and avoid crashes and monitor, drones can effectively monitor their own airspace in addition to a person monitoring the airspace to make sure they're not hitting anything or causing any damage, which, obviously, as you said, if you're one person doing it, it's bad, it's still one thing. But, if the Red Cross is doing that, crashing drones, that's a major problem. So I definitely don't have all the answers. But, I'm hoping some of these things can lead us to the answers or better questions like yours.
Yeah, thank you, Kevin. I mean, in the wider scale of things, 10,000 might be considered like expensive if we are thinking about a salary in South Sudan, right? But I mean, if we think about the cost of one single individual delegate that is deployed from one European national society to another country, might be like around this, in between the travel and the salary and all the things and the insurance and so on, no?
Right.
So is in reality the cost of 1 month of a deployment of one individual. So it shouldn't be like considered as expensive, I would say, like a 10,000 for a national society that has like the financial means.
Right. Yeah, I mean, our VSATs, our very small aperture terminal, our satellite communications connections that our ITT ERU has here, those are 30,000 plus each. Right. And that's a capacity that we can deploy and provide as needed. So I could see this being similar.
Yeah.
And I think with this type of technology, we've seen it already. What you're describing, Kevin, 12,000 today, and in 6 months, there'll be 5 other companies and the price point's down to 5,000 or something, right? So,
exactly.
But I wouldn't, personally, I'm not that concerned about that. If you said it was $100,000 and it was this novel technology that's hard to replicate, I'd be more concerned. It doesn't sound that. It sounds like an incremental innovation, right? An easier to deploy small drone, big deal. The price point will come down. China would be producing hundreds of them there in no time at all.
I'm sure.
What what it just, and we're almost out of time. Kind of what struck me is like there's been a lot of incremental innovation on the data management, on the actual hardware, on the integration of hardware software. It seems that the regulatory wet blanket is still there, and then like it seems like your whole industry in this very odd named conference you're at, they're advancing autonomy and all the things that I think technology is great at, obviously. But it's like there's this regulatory anchor that's preventing real broad deployment just yet, right? So it's almost like that's the rate limiter moving forward.
Yeah.
Does that make sense?
That 100% makes sense. You're absolutely right. I'm just looking. So the FAA, sorry, I'm pulling up on my screen. I won't go through it, I promise. Just released a 380-page document on beyond visual line of sight. It sounds dry and you know, a lot of stuff, but it actually, they are trying to work with industry and other stakeholders to come up with better solutions, right? The FAA doesn't want to just start letting people do things without really being aware of what that means and managing airspace risk, right? The worst case for the FAA is someone crashes something into a plane, right, and kills 200 people. So, you know, I understand kind of where their governing bodies come from. However, they are definitely trying to work with industry to improve that, right? They don't have all the solutions yet. There are a number of things happening at this conference here this week, actually, where the FAA is leading like a symposium and working groups specifically to talk about, you know, how do we better, you know, how do we get away from this, here's your rule, you have to apply for a waiver, to here's your checklist of things you need to check off to be able to get our standard approval and certification to do things like beyond line of sight and, you know, one-to-many operations. So it's something that the regulation is the long pole in the tent, but they are trying to work through that with industry.
Okay, because to me, I know we're both based in the U.S., so we're fixated with FAA, but this seems to be it is clearly a global issue because the misuse of drones, unfortunately, reflects on the good use of drones, and the regs are somewhat spotty and variable around the world. But this seems to me from a global reg cross perspective, kind of like the kind of an issue. We could always buy this technology. A lot of it's off the shelf now, and the price points are very reasonable. It's the ability for us to safely deploy and rapidly deploy. And if you have to wait for a waiver or many levels of approval, it's not consistent with a lot of the more rapid humanitarian missions that we had envisioned for the use of this. If it's, you know, if you could plan a month ahead for mapping, that's probably not a big deal. But in order to use this technology in an emergency, urgent situation, these regulatory issues are just in confrontation with the capabilities of the technology at the moment. So I think that's something we're going to have to continue to put some effort on.
Yeah, I agree. And I think we need to do more of a deeper dive and survey into, you know, one, globally, what do those regulations look like? I do know that there are some organizations, like I was talking to a company from Brazil yesterday, and their version of the FAA follows very closely on the heels of whatever our FAA does. And I wonder how common that is. I don't know. But there are also, like, the FAA has waivers that are a little bit eased for disaster response operations. So, you know, it's something to explore to get like knowledge of what those kinds of things are around the world. I think a lot of work to do that, I would think, but it's definitely the slower piece than the technology.
And the last quick comment before we wrap up, watching what's going on in Ukraine right now and how much drones have been utilized, you know, in many, many different ways. It worries me that the reaction a lot of regulatory authorities are going to have afterwards is, you know, some governments will be more amenable to it. Some are going to be a lot more concerned about the capabilities drones have. And I think I didn't appreciate that until watching what's going on. I even noticed here in the US, the drones are broadly used now in sports events, and they're flying over groups of people. A year or two ago, you just didn't see that. So this technology is rapidly moving forward. There's a lot of different stakeholders that want to use the technology, and the regs are just, you know, they're struggling to protect aircraft. I'm actually a pilot. I don't like drones when I fly, but
I don't blame you.
we have to find a way to coexist. So it's a much more a serious issue than I probably appreciated a year ago.
Yeah. There's, sorry, last thing, and I know we're at 8:34, so I'm going to wrap this up in a second. There's a whole nother industry that's related called counter drone technology. And, you know, part of that is enabling, like, you may have a fleet of drones, but can you detect if there are other drones not part of your fleet in the region that you're flying? And maybe, you know, on the military side, you know, there's always a do something about it afterwards thing. But even just being able to detect that, I mean, they're starting to put those systems at stadiums so that they know, okay, well, we're flying 1 or 2 drones, but we can tell if a drone that is not ours comes into our airspace. They're putting those, the big one is they're putting them at airports, right? So they can detect when drones are coming into airspace. So there's these autonomous counter drone things that can help with some of those issues or challenges. But anyway, whole nother topic of discussion. So I know we're at 8:35. I really appreciate everyone's time. And I will make sure that I get my latest set of slides to Dan. I may wait to send them out to the end of this week because I'm still at the conference for a couple more days, might learn more. But I will get those out to everyone. After that, please feel free to reach out via email or anything if you have other things you want to ask or other things you want me to look at or just want to reach out. So thank you very much, everyone. I very much appreciate it, and enjoy the rest of your day.
Thanks, Kevin. Well done.
Thank you, Kevin, man. Ciao. Bye-bye.